All right, let's take a look at quiz 4, number 1. I'm going to hit the general circumstance. I think several of you have some things that went wrong while you were trying to solve it. A vast majority of you got this correct, and that was fantastic. But let me hit a couple points that some of you have made in the process of trying to solve the problem. In a differential equation like this, number 1, you're given dy dx, and the goal is to actually calculate what y is. The answer to the question that is given in this problem is what is y? And you're asked in this case, because you're given a boundary condition about when x equals 1, y equals 5, you can give a particular solution to this problem. In the typical situation, if you weren't given that boundary condition, then a general solution would be required, because there would need to be a plus c, a constant being added on that you also could apply toward getting your answer for this situation. So you, in working the problem out, I'm going to switch over to my iPad, and so we can take a look at this, and get the quiz in front of you so you can see what I'm working through. But here's the question. So you're given dy dx. That begs the question, where did it come from? What's y? And that's the antiderivative. That's the section we're talking about now. And the boundary condition when x equals 1, y equals 5 is given as well. So we need to take the antiderivative of each term, add a plus c, and then plug in x equals 1 and y equals 5 and see what c is. That's the goal of the situation. So first thing is, we're going to now say y equals, the antiderivative means take the antiderivative of each term. Raise the power by 1. The 3 is out front. Raise the power by 1 and divide by that new power. Minus 2. X to the raise the power by 1 and divide by that new power. Plus 1. Got a constant term. Where did it come from? X to the first power is what you've got. You had x to the 0, now you have x to the 1. Divide by that new power, 1. But then you've got to add plus c, because this is a general, some constant could have been on there that you took the derivative of, and you don't know what that is. Now let's simplify this. So we end up with y equals x to the 3rd minus x squared plus x plus c. Right? And now, I hope you can see that by plugging in 1 and 5 for y, you can solve for c. Okay? I'm going to ask you to do the math on this one. All right? Do the math yourself. The answer is c equals 4. Several of you got different answers. You got 2, I saw 5, I saw 1. You need c to be equal to 4 to have this work, okay? Plug in 1 for all the x's and do the math all the way down, and 5 for y. And the answer should be c equals 4. So as a result, the solution, the particular solution is going to be this. That is the particular solution. That's the answer to 1a. We're saying, what is the particular solution? Okay, and then it says, the second part says to verify your particular solution by calculating dy dx. You're given y. Dy dx should be what we were given at the beginning of the problem. And if it's not, something's wrong. Okay, that's the first part. Calculate dy dx, make sure it's that first thing that you had. And it is, okay? You take the derivative of this and you get 3x squared minus 2x plus 1. That's what it is. And then it says showing the boundary condition works, show the boundary condition works, which means when x equals 1, y equals 2, 5, excuse me, it says y equals 5. So when you plug in 1 for x, and then you should get y equals 5 when you're done. And several of you got a variety of things here. You need to go through that slowly. It works. You plug in 1 for x, and then if you want to just plug in 1 for x and see if your answer is y, you could do that. Or you could plug in 1 for x and 5 for y and show that the left side equals the right side. That would work also. But that's the general problem, okay? So, and now calculate dy dx is part of what you need to do. And the answer should be dy dx is what you're given up at the top of the problem. And then also when you plug in 1 and 5, it should be two sides of the equation are equal, or you can plug in the 1 and it should turn out for x and the answer should be 5. Okay? Do that. And then I want to talk about number 2 also. All right, number 2, the situation here is that geometry, so they're asking for your calculate geometrically. I ask you to find the area under the curve f of x equals x minus 2 between 0 and 6. And what's interesting about that is under the curve is what we typically say. But in this case, part of the curve is under the x-axis. So in reality, this is to get you familiar with the idea that when it says, what's the area under the curve? Well, it's between the curve and the x-axis is what we're looking for, okay? So the first thing is to draw that line. The line y equals x minus 2. And that you need to do that on a decent graph. And notice then the y-intercept is minus 2. And the slope is 1. So if we go over 1 up 1 over 2 up 2, over 2 up 2, over 2 up 2, we've reached the end of what we've been asked to work with. We've got this line going forever, but we're concerned with going between x equals 0 and x equals 6, okay? So the area under the curve, it stops at 6. Well, you're under the curve between 2 and 6, but between 0 and 2, you're not under the curve. You're above the curve. And this is where I'm trying to get across to you. I want you to see that under the x-axis, the values are negative. And above the x-axis, the values are positive. So I'm asking you to find the area of the two triangles. Area equals 1/2 base times height. And the idea is 1/2, so this goes up to 4. So this side is equal to 4. And this side goes from 2 to 6, 2 to 6, so this side's 4. So you've got one triangle, 1/2, 4 times 4, 1/2 of 16 equals 8. So show your work on that, show how you get it, but the area of that triangle is 8. And the area of this triangle over here, you notice this side is 2, and this side is 2. So on that one, you get 1/2 2 times 2, which gives you 2. So what all I'm asking you to do is give me the areas. The question says triangle areas. What are they? They're 8 and 2. All right? And then plug it into your calculator. Plug this antiderivative. So for A, the answer would be the way I've asked it, is the area of the triangles are 8 and 2. Okay? That's what I said. And if you happen to notice there's a relationship there about 8 and 2, the area is positive, okay? The area is not -2 on the bottom of that problem. Some of you people wrote that the area was -2 underneath the x-axis. That's not correct. The area is 2. But when you're doing the calculations, you get the 8 is positive 8. If you do the integral from 0 to 2, notice what you get there. You get -2. But the area of a triangle is positive, always, all right? And so you've got 8, and when in the calculator, you get -2, so it turns out you're gonna get 6 for your final answer. So then when you go to 2B, I asked you to plug it into your calculator. Some of you didn't say that you did that. What I asked you to do was go from 0 to 6 of the function x minus 2 dx. Plug it into your calculator and just tell me that you get the answer of 6. Do it. Make sure it's right. And then the answer for 2A is 8 and 2. And you see the difference there? The idea is get familiar with the idea that above the x-axis is positive and below the x-axis is negative. Okay? So that's 1 and 2. I'll do 3 and 4 at another set. Good problem set, okay?